Hello and welcome. In this tutorial, I want to go over and review how to determine the number of solutions of a quadratic equation by calculating the discriminant. So here are some notes. The discriminant and the kinds of solutions to the form ax squared plus bx plus c equal to 0. If b squared minus 4ac is greater than 0, then there are two real solutions. If b squared minus 4ac is equal to 0, then there is one real solution. It's going to be a repeated solution. And if b squared minus 4ac is less than 0, then there are no real solutions. They're going to be imaginary, and we will record them as a complex number. Also, I want you to notice that the b squared minus 4ac, that pops up in the quadratic formula. It's the stuff that's underneath the square root. Now let's begin to calculate this with an example. Let's look at example number 1, find the discriminant, and then determine the number of real solutions. To find the discriminant, I need to calculate b squared minus 4ac. So I'll go ahead and identify all of the key values. The a value is going to be 2, b is going to be negative 6, and c is going to be positive 3. I'm going to go ahead and make the substitutions. So I have b squared, that's going to be negative 6 squared, minus 4 multiplied by a multiplied by c. A is 2 and c is 3. Let's begin to evaluate. Negative 6 squared, that's going to give me 36. And then we're going to subtract. 4 times 2 is 8. And then if we multiply 3, that's going to give me a 24. And 36 minus 24 is 12. So we're in a scenario where b squared minus 4ac is bigger than 0, right? The 12 is bigger than 0. Referencing our notes, we're going to see that we are in this scenario. We have two real solutions. So here we're going to say we have two real solutions. Let's view another example. Example number 2, find the discriminant, then determine the number of real solutions. For this example, we're also going to find the roots. So to find the discriminant, I need to calculate b squared minus 4ac. I'll label my key terms and then plug them in. So b here is going to be negative 6. So we get negative 6 squared minus 4 multiplied by a multiplied by c. The a value is positive 2. The c value is positive 5. So evaluating, I get 36. Negative 6 squared is 36. And then we're going to multiply 4 times 2, which is 8. If we multiply a 5, we're going to get 40. 36 minus 40 is going to give us a negative 4. So we got something that's less than 0. So here we got that b squared minus 4ac is less than 0. And referencing the notes, we can see that we're going to have no real solution. We're going to have imaginary solutions. We're going to record them as complex numbers. So to find the roots, I'm going to use the quadratic formula and recall that what's underneath the square root, that's the discriminant. That's this part. So I'm going to replace this by negative 4. So let's go ahead and begin to evaluate this to find the roots. So x is going to equal negative b. So negative 6. Plus or minus the square root of the discriminant, which is negative 4, the stuff we just calculated, all over 2 multiplied by a. The a value is 2. Now, because we have a negative underneath the square root, I'm going to make use of the fact that the square root of negative 1 is going to be I. We can exchange that for I. And doing so, we're going to get negative negative make a 6, plus or minus, and then the square root of 4 is 2, but we have that negative, so we're going to write it as 2i. On the denominator, 2 times 2, that's going to be 4. And on the numerator, the 6 and the 2, they share a greatest common factor of 2. So I'm going to go ahead and factor out that 2, leaving me with a 3 plus or minus I all over 4. Now the 2 and the 4, we can reduce that into 1/2. And our final simplification is going to be x equal to 3 plus or minus I, because the 1 is not going to affect the expression on the numerator, all over 2. And of course, you could also write these solutions or the roots individually. So we get 3 plus I over 2 and 3 minus I over 2.